I really like that game. It's pretty fun.
Okay, sorry guys for the little bit of the delay. So I'll answer homework questions, or I'll answer questions that were on the pretest 3. So we have the answer key to the pretest 3 here, and it was also posted on Blackboard. We went over a little bit of it on class on Wednesday. So if anything else, if anyone has any questions on anything, you guys want to start on, does anyone have any questions on 12.1? Organizing the data. 12.1 is pretty straightforward, right? Stem, leaf, plot, bar graph, histogram. There's not a lot of calculations there. It's just organizing it the way they want to organize it. Do you have a question on 12.1?
Yeah, the only thing I was confused about was like the random sets, the systemic sets, those type of questions. You know what I'm talking about?
No. Do you have an example?
Yeah, number no, it was number 15. It said in the back of the book was like a systemic, I think is what it was called. But I didn't really understand.
What's it asking you to do?
You had to define what kind of sample set it was, basically. Like it was
Classify each as random. Yeah, so stratify or cluster. So we talked about the 4 on the PowerPoint. If you go to the 4 classifications, for chapter 12, there are 4 types of ways to get your data. A random sample, so it has to have equally chance of being selected. So randomly picking out numbers, right? So if I give you guys a number in this class, I put it in a hat, and I was to pick out 3 people to get an A in the class, that would be a random sample, right? There's systematic. That's where you take every case person in here. So every third person's going to get an A. 1, 2, 3, they get an A. 1, 2, 3, they get an A. Or K, it's random. K is randomly selected, right? So that's systematic. And then there's stratified sample, and that's when you divide the population into groups that have similar characteristics. So I might say I'm looking at all 18-year-olds at OTC. So, and then members from that group are selected. So I'm going to select people that are in this specific group. So there's some organization there. And then a cluster sample would be like, I'm going to look at people that are in Math 128. Right. So we did some examples in the PowerPoint of defining the 4 types, the 4 different methods for picking the sample space. So if we go back to the homework from that section, right? Every 7th customer entering the shop, right? You would classify that as systematic, right? There's a system in place. Nursing supervisors are selected at random using random numbers in order to determine annual salaries. Random, right? So I'm going to pick out a number and pick that number of nurse on my chart. The mail carrier are divided into 4 groups, into gender, male and female. So that would be the stratified type. So those are just the 4 definitions that you're going to classify. So there are different ways to set that up. It's how you gather the data. Did you get it randomly? Did you do a systematic sampling, stratified sample, or a clustered? Are they all 18-year-old males that go to OTC? Are they all 18-year-old males in Springfield, Missouri? Does that make sense? It's basically just defining the definition, knowing the definition and matching it. Any other on 12.1? 12.2 had to do, 12.2 is actually picturing data with drawing the 3 types of charts. And that's pretty straightforward. A little time consuming, but not necessarily difficult. 12.3, again, the same type here. It was maybe a little time consuming to find the mean, the median, mode, and mid-range. And then to compare the 4 measures of average, it gives a nice little table in your book. Unfortunately, it's on 2 pages. Where did the little table go? About the benefits of mean, median, mode, and mid-range. Here they are. A median, mode, and mid-range. Mean, the strengths and weaknesses of mean, median, mode, mid-range. It's also in the PowerPoint, the same table.
We need to study that chart.
No, but you should have some idea. If I said, I might have like a word bank, mean, median, mode, mid-range, and then I have some statements. Like, it's easy to find, is unique, happens most often, and you have to match that word with that statement. So you don't necessarily have to memorize that table, but you should be able to relate those 4 measures of average to their strengths and weaknesses in a sense. You should have some inference from that.
That's 12.3.
That's 12.3, yeah. The end of 12.3 gives you that table. But 12.3 is calculating mean, median, mode, mid-range, and knowing the difference between the 4 averages. All of those are considered an average in a sense. Some averages are easier to calculate, some are more specific. If I talked about outliers, what affects outliers? That the mid-range is going to be most affected with outliers. Things like that. 12.4 was probably the longest calculation section because you have to calculate the mean. Then you have to calculate standard deviation, or variance and standard deviation. Variance and standard deviation are together. Standard deviation is just the square root of the variance. Standard deviation actually tells you something about the data.
I have a question on the test on number 7, which is
Okay.
with range, variance, and standard. Yeah, on the answer sheet, you have the range down at 4.3, which is the lowest, so 16.7. Yeah.
Yeah, I didn't actually calculate. It should have been subtract. So yeah, the range is just the difference, and I should have actually said 16.7 minus 4.3, which would be 12.4. Yeah, I should have.
Okay.
I should have wrote that, but.
I thought that's what you would want us to do, but then I saw the answer sheet and I was like, oh.
Yeah, I
Okay.
just got too excited about calculating variance and standard deviation and forgot to throw those 2 numbers in my calculator and come up with the number. Yeah, so the range, the 12.4 tells me how many points are difference between my first and my last, or my highest and my smallest. Interpreting standard deviation, not too much of that because that's really 12.6. 12.5 had to do with position. So knowing the difference between percentile rank and position. If I'm ranked number 1, I'm going to have a high percentile rank, like a 99 percentile rank. Some examples on the pretest that some students might have had some problems with. If a student's rank is 111, then you have to find how many people are less than that student, right? So that'd be 300 minus 111. That's how many people are below that student. Divide that by 300, and that's going to give you your percentile rank. Of course, you need to multiply by 100 in your calculator, or move the decimal 2 places. Yeah, again, number of students that scored lower divided by the total number of students is the percentile rank. Right? So if I'm asking what the percentile rank is, you need to find how many students scored lower than the person. If I give you the number of students that scored lower than the person, you can calculate the percentile rank straightforward. So both ways are possible. This one, I give you the percentile rank and I'm asking you to find the number of students that scored lower. Here I give you the rank and you have to find the number of people that scored lower to find the percentile rank. So that's probably some of the students struggle with, you know, I want to be ranked number 1 and I want to have a 99 percentile rank. So you want to have a high percentile rank or a low rank to be considered the top of the class or the top of the data. And then 12.6 is all about applying that to the normal distribution curve and finding how many data points will fall within a certain range, either to the right, to the left, or in between. Question?
Yeah, can you do a problem when you one between 11 and 15?
All right, so,
No, like on 12.6.
oh, on 12.6, 11 and 15? Okay, so we did some of these in class, and some of them also were on your homework, but 11 and 15, there's two ways you can approach it. You can memorize the empirical rule, and the empirical rule states that 68% of the data will fall within 1 standard deviation, 95 will fall within 2, and 99.7 will fall within 3 standard deviations. So 11 through 15, it gives you the exact 1 standard deviation, 2 standard deviations, or 3 standard deviations. So here, if the mean is 12 and standard deviation is 1.5, then 10.5 to 13.5 is exactly 1 standard deviation. So if I was to draw the curve and I would have 12, this would be 13.5, this would be 10.5. That would correspond to a z-score of -1 and 1. And if I look at the table, it's going to give me z equals 1. My area is going to be 0.448. I don't know, 68%. So this is going to be 0.341. But that only gives you half the table. So if you add it, you get 68%. Then you take that 68% and you multiply that by 50, and that gives you how many data points fall within that range. You can do the same thing with 12, 13, and 14, and 15. Here, this is standard deviation of 8 to 116. That's actually 2 standard deviations. That's 95% of the data. So 95% of 200 would give you 190. 190 data points fall within the yellow range. So that means 10 fall outside of that. Using the empirical rule for 11, 12, 13, 14, 15, you can just know those 3 standard deviation numbers. You could also use the table. But really where the table comes in handy is when you have a z-score of something other than 1, 2, or 3. And if you want to know to the left or the right, you can't use empirical data for that, or the empirical rule. Because the empirical rule is only 1 standard deviation, 2 standard deviations, or 3 standard deviations. So if I wanted to know everything to the right of it, I have to use the table. So yeah, we talked about this one in class a little bit. 2 ways to go about it. You can just calculate the z. You can calculate the z value for any number. Use your table, but that's going to be the same as using the empirical rule. That makes sense on that one? 2 approaches there. So that's 12.6. The printout, probably the most difficult one for students would have been number 15. You were given the mean and the standard deviation, and then you were asked to calculate 2 values that were not, or less than a certain number. So if I wanted to just look at one standard deviation, I went from 630 to 1590, but that doesn't help me because I want to know less than 751. So I already know 751 is somewhere between 0 and -1. Or yeah, $7.51 would be between $11.13 and $6.30. Different ways to do it. The easiest way, which I didn't write here, would be to calculate Z, which would be $7.51 minus $11.13 over $4.83. If I plug that in my calculator, would it be $7.51 minus $11.13 divided by 483? That would give me minus 0.749. And I rounded that up to minus 0.75. And that's where I kind of got this here. So I'm looking at Z at minus 7.5, which is really the same as 0.75. And I get this number. This is my area. And really that area is this shaded region from the table. So if I want to find the probability of it being less than it, I want to find the blue area. I'm going to take 0.5 minus the yellow, which I did here, to get the blue. So find the probability that a randomly selected employee earns less than $7.51, and this is the probability, meaning 22% of the population earns less than $7.51, or 23%. 22.7. So anytime it asks for probability, you can list it as a decimal or as a percent. They're equivalent. It's like saying 50 cents or half a dollar. Means the same thing. So 0.227 is the same as 22.7%. Does that make sense? It'll probably be one like this where there's an application type Z table. And then they'll just be straight Z tables. You know, do you know the difference between the area to the right, the area to the left, or the area between? This one is using the empirical rule here. If you know the mean and the standard deviation, so the first standard deviation would be between this number. 68% of the data points fall within the first standard deviation. So 68% times 40 would be 27 values, or 28 if you round up. You could have easily asked, you know, 2 standard deviations. The range could have been 2 standard deviations. Then you would know 95% of the data. Or 3 standard deviations, and you would know 99.7% of the data. So if it gives you something like this, you could translate 15.5 and 18.5 to z-scores, which would be -1 and 1. And find the area between -1 and 1 would be just like a problem like this. And look at the z-table, and it's 68%. It'll be a little bit over 68%. And that's why you could have 28 values. Q1, Q2, Q3 can be calculated. Straightforward. Percentile rank, if I give you a list, how many are below, count how many ones are below, divide by how many are total, times 100 would give you percentile rank. Any other questions on the homework or the pre-exam?
Can you do number 9?
So number 9 is asking how many students scored lower than someone that is in the 20th percentile rank. You're in the 20th percentile rank, you should know you're on the low end, right? Only 20% of the people kind of did better than you or at or equal to you, right? So there's two ways to look at it. You can calculate X. Let's see if we can calculate X. Yeah, so you can calculate X to see X is where she stands in her rank, but this number is how many people are below her, right? We don't know her rank, we just know her percentile rank. So we can directly do percentile rank. If we want to know percentile rank, the formula for that is N, probably not N, number lower divided by N times 100 equals percentile rank, right? N minus rank would be up here. That's like this example here. N minus the rank, you were given her rank. The student's rank is 111. N minus the rank is the number of people below her. Does that make sense? Right. So here you weren't given rank, so this one doesn't really help us. But 200 minus her rank would be the number of people lower than her. So the number of people lower than her divided by 200 is the percentile rank. We were given the percentile rank, so number lower out of 200 times 100, which if we just convert it to a decimal, right, 20%, the 20th percentile rank would be 0.2. So to calculate the number lower, you just take 0.2 times 200. Her rank would be N minus this number.
So 1 minus that.
200 minus that number, because N is 200. If it was out of 500 students, the process would be the same. It's just going to be divided by 500. So there's going to be more students lower than her, but she's at the same percentile rank. So that gives you 40. So 40 students lower than her. So she's ranked 200 minus 40. Yeah. So just depending, and this is probably the students get a little bit confused on, because percentile rank and rank, you have to be really careful what you have. If you have the rank, you have to take N minus that number, just find how many people are below them, divide by the total will give you the percentile rank. So you can have a percentile rank. If your percentile rank's really high, your rank is low. If your rank is low, then your percentile rank, or sorry, if your rank is high, if you're 57th in your class, then your percentile rank is going to be low. Makes sense? And then around 50, you could be ranked percentile rank of 50 and also rank of 50, just depending on the numbers. So in the middle, you could be close to that. So it should make sense here that a percentile rank is 20% and only 40 students are below her. Versus if you got a percentile rank of 80%, you would expect a lot more students to be below that person. Right? Because their rank is going to be higher. If you're ranked first, then you're in the 99th percentile. If you're the tallest person in your class, then if you're ranked number 1 as the tallest, your percentile rank is going to be like 99%, because you're taller than 99% of the population. So that's probably the things students struggle on here is, what do I have? What do I want? Do I want rank? Do I want percentile rank? Do I have percentile rank and want rank? Or do I have percentile rank and want how many people are below me? Which is along the same thing. If you can find their rank, you can find how many people are below them by just taking N minus that number, N minus the rank. And that's kind of what I try to highlight here. This is the rank. But I wasn't given rank here. I was given percentile rank. So I used this formula, which is a little easier. Any other questions? Number 7. Go through all of it.
How do you find the variance?
So the variance is, first you have to calculate the mean. And this is a hard one to grade because if you don't calculate the mean properly, it doesn't matter what you do. So your work is very important here. If I can see this work, but you punch a number in wrong, you're going to get most of your credit, right? I want to see that you took 4.3 minus whatever you got for mean and squared it. 11.3 minus what you got for mean and squared it. If you calculate the mean wrong, you're not going to get any of the answers for standard deviation or variance correct, but I can give you most of the points because I can see your method. If you plug it all in your calculator and only say, oh, the mean is this, the variance is this, the standard deviation is this, you're not going to get any points. So if you can show me something like this and put in the numbers, you'll get most of your points for this problem.
So I just didn't even know how to
Calculate it?
get it, so that's.
Yeah, so the book formula is x minus, actually I think it's x minus x bar, but it doesn't really matter the order because you square it, divided by n minus 1, and then you take the square root of that. That is the variance, or standard deviation. Before you take the square root, that's called variance. The variance doesn't give you much as far as application. You want to always use standard deviation for application. And the square root of variance is standard deviation.
To get the standard deviation, you take the variance.
The square root of that. So you just hit your square root button in your calculator of what you calculated of all this. Common mistake here would students divide by n instead of n minus 1. So you'd lose points for doing something like that. And you might do some kind, on calculate the mean twice, maybe, plunge the 6 numbers in your calculator, divide by 6, do it again. If you get the same answer, you say, okay, my mean is probably correct. If you get a different answer, you want to do it again and say, oh no, be careful the way, it's super easy to hit the wrong button and not even kind of notice that. Any other questions? Mid-range, you add the 2 lowest and highest together, divide by 2. Range, you take the lowest or the highest minus the lowest.
You said you're gonna provide us with a table.
Yeah, you'll have this same table that I gave you on the back of that handout. Depending on the problem, if I know you're only going to use like the top part of it, if you're only going to use z from 0 to 1.74, I'll make it a little nicer to read, but I hate to get rid of part of the table and it then be on the exam, so I have to be a little careful because sometimes I just randomly pick questions. I want to make sure if I put the whole table, it's there.
On number 5,
Mm-hmm.
the frequency polygon, do you need to start at 0 and?
You can. I'm not going to take off points if you don't.
Okay.
Since this is kind of listed 40 to 99 in the grades, 0 students got 0 and 0 students got above a 99. You don't really need that. Different books stress it different ways. This book always went down, but they never said you needed to. Technically, a polygon is a closed figure in geometry. A polygon would be something that our sides are line segments, but are still closed. Versus if I just have something like this, it's not technically a polygon because it's not closed. The reason why they close it is because then it has area. An area corresponds to percent of the data within a certain region. So the area here would be 1. We would expect half the data points to fall on one side and half to fall on another. That only works with normally distributed things. This looks pretty normally distributed, and that's another way you can kind of tell things are normally distributed by looking at the curve. But if I had something like this, that would not be a normally distributed curve. If I cut the data points in here, obviously this area is a lot larger than the area to the right or left of it. It's not the same. So that's one way to show data points follow a certain pattern. And if you're using some kind of statistical analysis of running experiments and you want to apply the empirical rule or you want to apply the z-table, you have to show your data follows a normal distribution. And so you have to be able to calculate and show the mean and the median and the mode are the same numbers or within a very small range of each other, and you have a normally distributed curve. So half the data points are to the left or half to the right. If you can show that, then you can say, okay, if this was a number here, I could calculate the z-value and then look at that table to find what are the data points in this range. With polynomials, you can find them by using geometry, area of a square, area of a rectangle. You can find the area of a square and an area of a rectangle, you know the area. But in the application, they're more curves instead of line segments. So I can't necessarily find this area by using geometry. I have to use calculus, and we don't have calculus, so we use the z-table. But yeah, that's more advanced than we get to in this course. So very long-winded explanation for a simple question, but yeah, this would give you full credit. If you went ahead and did this, you would get full credit too. I wouldn't count off for that. Probably technically I should do this. I teach the same material in different books, and other books don't stress it. They just do this. Any other questions? I know it's kind of been a long weekend for you guys to jump back into some of this, but
It'll be all right.
yeah, you kind of have to, if you give yourself maybe, 30 minutes before the exam to look back over it, it would be probably helpful if you have that time just to jumpstart your brain before getting to the exam.
Yep.
Any other questions?
Thank you.
All